Hey, what's up? Tough problem here, but a great example of what you'll want to do when you see exponents and addition and subtraction within the same problem. Now, to be super clear, this is when you're adding and subtracting with the bases, not within the exponent itself. When you're adding and subtracting within the exponent itself, you're going to want a slightly different strategy. But when you're adding and subtracting with bases in exponents and roots questions, you always want to factor out a common term. If you don't know what factoring out a common term is, you might need to brush up on your math basics. Feel free to reach out to us anytime and we'll be happy to help with resources for that. But just so we're on the same page for the purposes of this lesson, let me talk about what factoring out a common term means briefly. Let's say you've got 6 plus 9. When you're factoring out a common term, you're looking for a number that divides 6 and also divides 9 evenly. In this situation, that would be the number 3. So if I divide both of them by 3, what I can do is pull the 3 out of both terms and put that 3 outside a set of parentheses. 6 divided by 3 is 2. 9 divided by 3 is 3. And then if we just add up what's within these parentheses, you can see that we've transformed something that used to be addition into something that is now multiplication. And it's always better to be dealing with multiplication in exponents and roots questions because it allows you to use many of the shortcuts that you've probably memorized for exponents and roots, such as multiplying by the same base, I add the exponents, dividing by the same base, I subtract the exponents. And those rules just don't really apply nearly as well or as often when you're adding and subtracting the bases. Hence the desire to factor out a common term when we see this kind of situation. Now, this is definitely not a simple or easy version of this concept, but it's still a great version of how this concept plays out across the difficulty spectrum. So this would be an example of how it plays out on a harder question. Now, there will be a nice little bonus here at the end when we dig deeper into the whole, like, why are they asking me about 2 to the negative 17th thing? But for now, let's go with the more intuitive approach for most people, which would be looking at this and seeing, oh, 2 to the negative 14th is something that exists within all 4 of these terms. Similar to the way you probably can look at 6 and 9 and say 3 exists as a factor within 6 and within 9. Now, if you haven't developed that kind of pattern recognition of being able to look at 2 to the negative 14th, 2 to the negative 15th, 2 to the negative 16th, and recognize that 2 to the 14th can be pulled out or factored out of those terms, then you'll definitely want to invest in your core exponent knowledge. Again, just reach out to us anytime and we'll be happy to make some recommendations about resources to help you grow your basic exponent skills. But if we assume that you understand and can at least theoretically recognize that 2 to the negative 14th exists within all 4 of these terms, then we can proceed with our core strategy. If you follow my work, one thing you're going to hear me talk about a lot is visual organization in the quant section. And I think that that's something that's extremely underrepresented in terms of importance, in terms of value, and just in terms of how much people talk about it. Because the truth of the quant section is you could know all the material, but if you don't have a visual organization system that allows you to get credit for that material on a regular basis, guess what's going to happen to your score? Nothing. And that's really, really frustrating to be investing the time, seeing your skills improve, but then not seeing your score move. That's exactly what I went through when I was originally studying for the exam. If you want to learn more about my story, just head to our website and I'll be happy to share. For now, let's just proceed with our approach here and divide each one of these by 2 to the negative 14th. 2 to the negative 14th divided by 2 to the negative 14th is just 1. 2 to the negative 15th divided by 2 to the negative 14th is going to wind up being 2 to the negative first power. And if you haven't memorized that when you're dividing by the same base, you subtract the exponent in the denominator from the exponent in the numerator, then you'll want to memorize that. Negative 15 minus negative 14 is going to turn into negative 15 plus 14, and that will equal negative 1, hence 2 to the negative first. And then you're probably going to see, if you understand that, how the pattern's going to play out for these next two terms. This will be 2 to the negative second and 2 to the negative third. Now, just to make sure I don't make any terrible mistakes here, I'm going to pop my denominator back in, and then I'm just going to run the numbers up here. And this is why I was saying, like, it's a little more complicated than something like this, but I think the problem still becomes doable if you take this route. If you don't know what negative exponents are, that's just 1 over the positive version of the exponent. So within these parens here, I'm going to wind up with 1 plus 1 over 2 to the first power, which I'll just express as 1/2. This will be 1 over 2 to the second power, and this will be 1 over 2 to the third power. Now, doing fraction math honestly isn't my favorite thing to do during the exam, but every time I'm presented with something like this, I think about the upside of an MBA, and I think, okay, on average about $100,000 extra per year, maybe $10,000 extra per month, and that's if I never get a raise ever again after business school. And these are just averages, and not saying it's all about the money. It's obviously not. But money doesn't hurt, and it's a easy, convenient scoreboard to think about ROI of time spent and like kind of quell the negative voice of like, I don't feel like doing this right now, which definitely comes up for me when I'm about to do some fraction math on the exam. But perhaps obviously that's super short-sighted and me just being emotional and not rational. So I like to remind myself like, hey, we're doing this because we're going to grow our impact and our income. And it's really tough to go wrong growing those two things as long as the net impact is positive, of course. So just something to help your mental game if that's a particular struggle area for you. And if it's not, great, good for you. Adding fractions, I just want to focus on a common denominator. I can see here 2 to the third is going to yield 8. So I'm just going to express everything in terms of a common denominator of 8. So I'm going to multiply this by 8 over 8. I'm going to multiply this by 4 over 4. I'm going to multiply this by 2 over 2 because 2 squared is going to yield 4 in the denominator. And this will just stay 1 over 8 here. So I'll wind up with 8 over 8 plus 4 over 8 plus 2 over 8 plus 1 over 8. Okay, let's run the numbers here. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So I'm going to get 15 over 8 here inside my parens. And now I can progress to the next step of this overall expression. So 2 to the negative 14th out here hasn't changed. I've got 15 over 8 right here. And then I've got divided by 5. Now, you might not love this, but it's still progress, and let me show you why. A really important principle in exponents questions is always try to make as many bases of the exponent the same as possible. What I mean by that is I've got a base of 2 with this exponent, and 8 can be reduced to a base of 2. Focusing just on the numerator here, I've got 2 to the negative 14th right here, and then I've got 15 divided by 2 to the third power. Now what I'm going to do with 15 over 2 to the third power is I'm just going to rewrite it as 2 to the negative third times 15. Now I can't really make this a base of 2, so I'm just going to leave that as 15 for now. So let's take a look at what our overall fraction would look like here, moving the 5 over from the denominator. So at this point, I've got 2 to the negative 14 times 2 to the negative third times 15 in my numerator. And then I've got 5 hanging out in the denominator. And if you're not sure how I get from here to here, again, that's very foundational fraction and exponent work that I'd prefer not to cloud this particular lesson with. But if you need help with that, again, just reach out anytime. Now at this point, I've got some really good news for myself, which is I can start combining certain terms and canceling out other terms. So for example, I can cancel the 5 and 15 with the 5 in the denominator, and then I get rid of the fraction, which is always nice. And I've got a 3 hanging out over here because 15 divided by 5 is 3. What I can also do is multiply by the same base here, and remember that I'm just adding the exponents when I do that, and so I'll wind up with 2 to the negative 17th times 3, which is fantastic news because what is my question asking me about? It's saying, how many times the value of 2 to the negative 17th is this thing? And right here, I've got my answer. Bam! It's 3 times 2 to the negative 17th. I took this expression and just reduced it, all the way down to 2 to the negative 17th times something, and bingo, I'm picking C, and I'm one step closer to grad school. So some reasons to like this particular solution path. I think it's the most intuitive out of the solution paths that I'm going to demonstrate to you right now. A good number of you are probably going to be able to look at this, recognize it's an example of this situation. I'm adding and subtracting bases of exponents and roots, and therefore I should factor out a common term. And then you'll probably be able to recognize that 2 to the 14th exists in each one of these terms. So that's what I would like about this solution. What there is to dislike about this solution is it's a little long and it's pretty computationally intensive. There's a lot of fraction math to do. There's quite a bit of exponent math to do. And most of us tend to be very error prone with both of those things unless we've really conditioned ourselves to have an amazing visual organization system as we're working through problems. So why don't we back out and take a look at some examples of solutions that are probably not super intuitive for the vast majority of people. They might be intuitive for some of you. And let's talk about some of the virtues and vices of those as well. And probably my second favorite solution to this question that I see a good number of people do, maybe 20% of students are going to just automatically resonate with this, is just set up an equation. You just set up an equation with what you've been given in the problem. Let me show you what that would look like. So the value of blah, this thing, is pretty much always means equals in an algebraic translation situation. How many times, okay, I don't know how many times I need to multiply by this thing, so I'll create a variable. Let's just keep it simple. We'll call it x. How many times the value of this, 2 to the negative 17? And this is definitely a nice way to set up the problem But again, for 80% of you on average, it's not going to click the first time you see the question, and that's okay. It's definitely the kind of solution you could recondition yourself to by repeating this problem on a regular basis and or creating some flashcards. So let's walk through this solution and let's talk about why you might want to recondition yourself to do it this way in the future. What's really nice about this is the question is basically just asking me for the value of x. And if I can recognize that, which again is not necessarily intuitive, but if I can recognize that, then really my job becomes somewhat simple in the sense that I just need to isolate that variable, and all I have to do to make that happen is divide both sides of the equation by 2 to the negative 17. Now this approach is kind of a bummer in the sense that it creates this double-decker fraction or triple-decker fraction depending on how you're looking at it, and that can be a very error-prone situation as well. So as much as possible, what I would recommend if you find you make a lot of algebraic mistakes, if you don't worry about this, but if you find you make a lot of algebraic mistakes, one thing I can recommend here is stop dividing both sides of the equation by anything when you're doing algebra, and instead just build the habit of multiplying by 1 over that thing. So instead of dividing, always multiply by a fraction instead. Multiplying by a fraction and dividing, it's the same thing. 1 over 2 to the negative 17th times 2 to the negative 17th is just 1, so that basically disappears from the left side. But it'll make you a little bit less error prone when it comes to doing the math on this side of the expression. And it's a small but mighty tip in that regard, because the fewer questions you miss that you know how to do, the better score you're going to get and the less friction you're going to create in this whole process. So when I'm multiplying fractions, if you're just starting out, you're just going to multiply straight across the top and straight across the bottom of both fractions. So the top of this expression is not going to change, and the bottom is just going to become 5 times 2 to the negative 17th. Okay, and that gives me x. So the virtue of this solution path is fewer steps. The drawback is it's much, much, much less intuitive and a lot harder to see the path through the problem. And for the vast majority of students I've worked with over the past couple decades, it's much better to get the problem right a little bit slower than it is to just fail at a quote-unquote more efficient approach. And you can definitely get sucked into some of these faster approaches that have fewer steps, but they wind up not moving your score because you're just not that kind of person who's going to recognize when to use that like slick technique. Now that's where the reconditioning thing comes in, and I would recommend you build the belief in yourself that you can recondition yourself to do the problem this way. But in the short run, or if you're taking the test soon, I definitely recommend just accepting that it's okay to be a little bit slower and right than it is to be fast and wrong in a lot of situations. And if you really think about efficiency at the end of the day, a fast approach that doesn't get you the desired outcome is not efficient at all. It's horribly inefficient. Okay, so speed doesn't always equal efficiency, but efficiency always equals speed. And sometimes the more efficient approach is going to appear slower in the short run, but actually be a better bet for you personally. But if you're looking at this and you're thinking, oh, this is no big deal, this is awesome, I can clearly see how I'm going to just divide each one of these terms by 2 to the negative 17th, then you're probably loving this solution and everything's probably turning out great. So if that's not intuitive for you, let me demonstrate it visually in a way that might make a little bit more sense. What I'm going to do is I'm going to separate the division by 5 because that could make it look like I can't really combine the terms I have in the numerator and the term I have in the denominator for some people. And I think just visually separating that as 1/5 times this other stuff is both mathematically accurate and also quite advantageous to helping you see the next and critical step to this solution path. What we can do here is start to combine by canceling the base of 2 in each thing in the numerator with the base of 2 in the denominator. And once again, let me visually organize this a little bit better way for you. Side note here, if I have 7 plus 5 plus 3 all divided by 17, I can reorganize that as 7 over 17 plus 5 over 17 plus 3 over 17. And for most of you, you probably wouldn't hesitate to go from here to here, but it might be a little bit less natural for you to go from here to here. And that's okay. Again, probably worth reconditioning yourself to just see that as an opportunity. So I'm going to write that out the following way here. And again, if you don't need to visualize it this way in order to understand the solution path, that's fine. I just want to break it out this way just in case some of you folks watching are like, wait, what? How do I combine those? Okay, so this would be one way to break out the fraction to help you see exactly what's going to happen with all this fraction math. And I think this is where the cool stuff happens in the problem, because once again, when I'm dividing by the same base, I simply subtract the exponent in the denominator from the exponent in the numerator. Negative 14 minus negative 17 is going to be negative 14 plus 17, and that's going to give me 3. So I'll wind up with 1/5 times 3. 2 to the negative 15 divided by 2 to the negative 17. That's going to give me 2 to the second power. Negative 14 minus negative 17 is the same as negative 14 plus positive 17. And that's going to be 3. So I'll wind up with 1/5 times 2 to the third power. And let me make sure I keep my parentheses straight here, since now I have this multiplication of 1/5 is technically applying to this whole situation. Let me use some brackets instead of parentheses. I think just visually that's a little bit better. And don't be afraid to make those visual adjustments midway through a problem if you're concerned you're about to make a mistake. Pay attention to that instinct that says, hey, you might make a mistake here. That voice is helping you out a lot on the test. Okay, negative 15 plus 17, that's going to be 2 squared. Negative 16 plus 17, that's going to be 2 to the first. And then 2 to the negative 17 divided by 2 to the negative 17 is just 1. All right, so now I can just run my numbers in this step. This is going to become 8. 2 to the third is 8. 2 to the second is 4. 2 to the first is 2. And 1 is 1. So I'll wind up with 8 plus 4 plus 2 plus 1. Let's move that over here. 1/5 times 8 plus 4 plus 2 plus 1. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So we'll wind up with 1/5 times 15. And I cut this off before, but the other side of this equation is equals x, equals x, equals x, and then equals x. And so we will cancel our 5 and our 15, and no surprises here since we already solved the problem a moment ago, that we get x equals 3. So I think it's debatable whether this solution is going to be better than the previous solution, because you wind up doing a bunch of fraction and exponent math almost no matter what, and that's part of what makes this particular question a high difficulty level problem. But I think it's a solution path that is worth discussing because for, again, on average, about 20% of you in my experience are just going to resonate with that setup a little bit better. And what you'll find in most word problems is it's all about the setup. And if you can get the setup right, then the execution is going to be a lot easier. And if you botch the setup or you rush the setup, it's probably going to create a lot of problems downstream. Those are my personal 2 favorite approaches to this question. If you have questions about this problem, feel free to reach out. And if you'd like to learn how to reach your dream GMAT score faster at no cost, just head to our website and we'll be happy to hook it up. Talk soon.